In this next demo, using this setup, we are going to be heating potassium chlorate. And that's what we've got in that test tube right there. I've got this other test tube. You can see that it's just kind of, see if I can get it to focus. There we go. Some white crystals, kind of plain looking. Maybe looks like some kosher salt or something. Not anything too interesting. But we are going to heat this, and even then it's not necessarily going to be super interesting, but then we're gonna, make it a little more interesting, because of course that's what we want. So I'm gonna actually set you guys against that test tube rack so that you can observe this stuff happen from close up. All right, now we are heating that potassium chlorate. I'm going to go ahead and turn the lights off in here just so that you can get a little bit better view of that. So we are heating our potassium chlorate, and you can see it starting to change there. I'm going to give it a little bit of a tap to mix it up and get the whole thing going. Now, like I said, this is not the most interesting of changes, but hopefully you can take some time while this is getting going in order to write your stuff and answer some of those questions. I might have put too much in. It's taken forever to get going. Hopefully you can see some of those bubbles. You can probably hear it when I'm not making a noise. And bubbling away in there. And this is what I want you to write your observations of. This is the change that I wanted you to see. But after you write out your balanced chemical equation, you'll notice that we're making a rather useful chemical here. And one of my favorite things to do with that chemical is use it to ignite some other chemicals. So I'm going to add a fuel source to this, because we are making oxygen. We are able to use that oxygen for combustion. We've got the heat, we've got the oxygen being made, all we need is a fuel. So what I'm going to use as a fuel is a Sour Patch Kid. The sugar on the outside helps it not stick to the sides coming down like a gummy bear would, and these definitely have plenty of fuel to get this reaction going. So I'm going to slide this guy in, bring down my sash to protect myself, and you can observe firsthand. So this is the aftermath of all of that happening. And as you might have noticed, I was able to pull the Bunsen burner out from underneath that after the combustion started, because the heat was already kind of formed. So it got the ignition started, and then that combustion was producing heat, which broke down more, produced more oxygen, so it could combust, and then that produced more heat, which broke down, made more oxygen so that the fuel can combust. This is what we call a self-sustaining reaction. And if you were thinking that it looked a whole lot like a rocket engine, you are absolutely correct. They use similar principles. They use a compound that can break down and release oxygen when it's heated, and that's what they use to burn and combust things in space where there's no oxygen. It's a little more complicated than just potassium chlorate, but it is a similar idea. So remember that the change that we were focusing on was the first change that we saw happen in the test tube when we were heating the potassium chlorate. The white crystals that were in the test tube, and that was all that was in there. So we were just heating that, and what this says and reminds us is that we were forming some potassium chloride, which conveniently enough for us, when we're putting these two elements together, because there's no prefixes in the name, and we do have two elements together, and we don't need to worry about prefixes and what they represent. We need to worry about charges, And the charge of potassium is a +1 because it's in the first column, and chlorine is a -1 because it's over there in the halogens column, second to last. So they just cancel out, no need to cross drop, reduce, or add any subscripts here. And this potassium chloride was the white speckledy stuff that was all over the floor of the vent hood after all of this had happened. It got formed from this first change, but because it wasn't used up later, it just got thrown about. And of course, we're making that oxygen gas. That is just oxygen, so just O, but we have to make that O2. When we write oxygen by itself, it has to have a 2 on it because it's a diatomic. So this is the chemical equation that I need you to balance and write on your piece of paper, and this is the equation that you should be focusing on when reflecting on the questions underneath this video.